Hello. Yeah, hello everyone. I'm Bhrigrishi Mishra, PhD student at IIT Bombay, and this is the online session of elements of solar energy conversion. So in this 1 hour online session, I'll talk about the topics covered in week 4. So basically, I'm taking lecture 9 and 10, and lecture 11 will be taken by another TA, Mr. Pawan, in tomorrow's online session, which will be held around like 6 to 7 p.m. at the same time, but tomorrow. So we'll start. So in week 4 lecture, mainly the derivation of the angles were covered. So earlier we consider that the zenith angle, hour angle, declination angle, azimuth angle, solar azimuth angle, surface azimuth angle. So we saw these angles. So in this in week 4 lecture, the derivation of these angles in a global way. Okay, earlier we were using that for a local or a standard reference frame, but then in this week we derived it for the local reference frame, since uh, these angles will be different for a for a different location, and we need to calculate these angles for a certain location, so that we can put our solar photovoltaic cell or our other water heating devices accordingly, since we need like solar noon for Mumbai is not same as solar noon for Kanpur or for Delhi. So we need to adjust or we need to calculate these angle with the reference of the particular location. Okay, and then we talked about the central angle, surface angle. So all those angles. So for example, if I have a plane here, okay, this is, if I assume it as a earth surface, okay, this is the this point is on the surface of the earth, and this is the center of the earth, O. Okay, so let's say it is P. So the vertical to this point will be like this. So if I connect the center of the earth to this location, it is, and the projection of this plane on the equator plane, and if I connect these lines, this angle is called the latitude angle. Okay, and if sun rays are coming, like sun rays are parallel, so one this and other is this, so this angle is theta z, and this angle which is making it here, this is the declination angle delta, and this we can say this is omega, our angle. Okay, so you can see this theta z, and similarly there will be surface azimuth angle, solar azimuth angle. So these all angles we consider from the surface. Okay, so these are called the surface angles. However, this latitude, uh, declination angle, and the hour angle, these we consider from the center of the earth. That is why these are called the central angles. Okay, so you need to remember these things. Other than this, we also discussed, I mean, it was discussed in the videos the the concept of the hour angle, okay, and also the concept of the solar noon. So basically, what is solar noon? So solar noon is the time when when the sun crosses the meridian of the observer's location. Okay, so for example, when this is, consider this is the prime meridian and this is the observer's meridian, where observer is somewhere here. Okay, this is P, so this is the local meridian. Okay, so when sun crosses this point, that means sun is at the top of the observer's head. Okay, so that position is known as the solar noon. Okay, and it is considered like 12 noon, or I can say 00, whatever you want to consider. Just generally it is considered 12 noon. Okay, and our angle is considered 0. So our angle is considered with respect to this local solar time. Okay, so our angle is 0 for this case. And we also saw that the sunrise angle is negative in the morning and it is positive in the afternoon. Similarly, gamma s is positive in west and sorry, not gamma s, here we are using AZ. Okay, so AZ, that is solar azimuth angle, and negative in the east. Yes, so it is negative in the east. So you need to remember, I mean, you cannot remember the formulas, the big formulas, but you need to remember these terminology. Then only you can calculate the incidence solar incidence angle correctly, because our main goal is to calculate the incidence angle, because any device which we will put on a certain location, we want to uh, utilize the maximum amount of solar energy coming on that location, that particular location. So that is why it is important to calculate incidence angle, solar radiation incidence angle, very correctly, very accurately, either on the horizontal plane or and some collector which has some tilt angle. Okay, we will see later what should be the exact tilt angle, so that we can utilize the maximum amount of solar radiation. But for this we will just consider the angle of incidence. What should be the angle of incidence, so that we can calculate the total radiation hitting the hitting our collector or hitting the solar panel, solar photovoltaic panels. Okay, so for that it is important to consider these sign conventions when we need to consider our angle positive, or sorry, this is omega, simply omega. So omega, that is our angle in the morning is negative, our angle in the afternoon is positive, and so thus the sunrise hour angle which is in the morning will be negative, and sunset hour angle will be positive. Okay, so I have considered two problems for this case, where we will calculate the angle of incidence, the solar azimuth angle, and hour angle for some particular locations. Okay, so the first question is, calculate the angle of incidence of beam radiation on a photovoltaic array whose slope and surface azimuth angle are 28 degree and 20 degree respectively, located in Mumbai. These are the coordinates of the Mumbai, latitude, longitude, for 18th August 10:30 hour. Okay, so so first we need the formula. Okay, so the formula to calculate the angle of incidence on a particular slope. So like this is my surface, and the slope is beta. So I want to calculate the angle of incidence which sun is hitting to this surface. So suppose this is some theta t. So the formula which derived in the lecture, cos theta t, is sin delta sin L cos beta plus cos delta cos L cos omega cos beta plus sin omega cos delta sin AZS sin beta minus sin delta cos L sin beta cos AZS plus cos delta cos omega sin L sin beta cos AZS. So you can see there are a lot of variables. So we for to calculate the angle of incidence for that particular surface, we need to know the tilt angle, which is beta, and so beta is given. Beta is 28 degree, and we also need to know the surface azimuth angle, which is given AZS equals to 20 degree. What else we need to know? The latitude. So latitude is given for Mumbai 19 degree 7 minute north, and if we convert it in the degree, so it will be 19 plus 7 by 60, which is around 19.12 degree north. Okay, and what else we need? We need to know, so we have this latitude, beta, and azimuthal angle, surface azimuth angle we have. We further require delta as well as omega, our angle. So the time is given 10:30, so we can calculate our angle. So if the time we calculate our angle based on the solar noon. Okay, so considering solar noon at 12, so omega is basically the time, the solar time of that position minus 12 into 15. 15 is because in 1 hour earth rotates 15 degree, that is why. So omega is in angle. Okay, and since omega is angle, so it will be in the degree, that is why 15 is here. So to convert it in the angle, so ST is given 10:30. So this is in the hour. We need to calculate, we need to consider in the standard time, so it is 10.5, because 10:30 is nothing but 10.5 hour. Okay, so 10.5 minus 12 into 15, and it comes minus 1.5 into 15, minus 22.5. so minus 22.5 is your hour angle. Okay, because so minus is since it is before the noon. Okay, as we have talked about here, that omega negative in the morning and positive in the afternoon, and the time is given here 10:30 hour, which is in the morning. Morning means before noon. Okay, so we have beta, L, AZS, omega, our angle. Now we need to calculate the delta, that means the declination angle. So declination angle delta is uh, 23.45 sine 360 by 365 284 plus n. Okay, now we need to calculate the n. So here it is 18th August. Okay, so n will be 18th August, but how we can calculate n? So it is starting from the 1st January. Okay, now it is August, so you should remember, I mean, at least how many days are in the month. So that is where you can calculate, it is the only way to calculate this n. So we'll start from the January. So we'll count the end of the total number of days in that month. So January 31, then February 28, March 31, then April 30, then May 31, June 30, July again 31, and then August, and we have 18th August. So it is 18. If you sum these numbers, it comes around 230. Okay, so n is 230, and now we can calculate this delta. So delta will be 23.5 sine 360 by 365 284 plus 230, and if I can use the calculator, so it will be sine 284 plus 230 into 360 divided by 365, so it is 23.4 sine 506.95, and if we calculate this, so it comes around 12.78, 12.7858, which we can consider 12.79 degree. Okay, now we can calculate the this incidence angle, because we needed to calculate the angle of incidence of beam radiation on this photovoltaic array. Okay, so now we have all the values, and now we can simply put in the formula, and we can calculate it as cos theta t. So if you put all these values in the calculator, so you will get a cos theta t around 0.913. I have already have the answer here, so you can calculate just to check again. Okay, so the theta t will be cos inverse 0.913, so it gives 24.01 degree. Okay, so the incidence angle will be 24.01 degree on this photovoltaic array located in Mumbai, whose slope is 28 degree, and the azimuth surface azimuth angle with respect to south is 20 degree at 10:30 am on 18th August. Okay, so if there is any question, please ask, or else I'll move to the next question. Okay, so I suppose no question. So the next question is, calculate the time of sunrise, solar altitude zenith, and solar azimuth angle for a 60-degree sloped surface facing 25 degree west of south at 4 p.m. solar time on March 16 at a latitude of 43 degree also calculate the time of sunrise and sunset on the surface. Okay, so there are a lot of things which we need to calculate. So first let's see what are the values given. So for a 60-degree sloped surface, that means beta is given, beta is 60 degree, and surface facing 25 degree west of south, that means the surface azimuth angle is given as 25 degree. Okay, so AZ dash is 25 degree, and since it is west of south, and I have told you that if surface azimuth angle is in the west of south, we will consider it as a positive number. Okay, so AZ dash will be 25 degree. Next, so and it is given west of south at 4 p.m. solar time. Okay, so west of south means we can calculate the omega. So omega will be uh, so yeah, again with the same formula like we have calculated this one, this formula st minus 12 into 15. So we can use the same formula to calculate the omega here also. So st simply, so it is 4 pm. Okay, so pm means we need to add 12 also, so 12 plus 4, so 16 minus 12 into 15, so it is 60 degree. Okay, so the omega is 60 degree. What else we are given? Latitude is 43 degree, and the n number of day, March 16. So n is March 16. March 16 means again 31 plus 28 plus 16, which is 75. So n is 75. Now we need to calculate the time of sunrise, solar altitude, zenith, and solar azimuth angle. Okay, so time of sunrise, we have the formula. Okay, omega s equals to it is cos inverse minus tan phi tan delta. This is the formula to calculate omega s. Okay, so but this is for the horizontal surface. Okay, first we will calculate all the quantities like sunrise and this sunrise angle for the horizontal surface, and then we will calculate it for the sloped surface. Okay, so omega s is cos inverse minus tan phi tan delta, so it is cos inverse it is tan L. Okay, in some book latitude is considered used with phi notation, so that is why I put phi here, but since we are using with the L notation, so I am sticking with the notation L. So omega s, which is omega s is what? Sunrise or sunset hour angle. Okay, so it will give the sunrise hour angle and sunset hour angle. So negative, so omega s negative is sunrise hour angle, omega s positive is sunset hour angle. So if we have this L delta, sorry, we don't have delta, we yet to calculate delta. So if we calculate delta here, again these are the small formula which you can easily remember, not the big one, but yeah, when you practice the questions you will easily remember this formula. Sine 360 by 365, 284 plus 75. So if we calculate this delta, it is 23.45 into sine 360 into 284 plus 75 divided by 365. just a minute. It's 284 plus 75. So it is around minus 2.4177 minus 2.42 degree. Okay, so this is the delta, and now we can calculate omega s. So omega s is cos inverse minus tan 43 degree and tan minus 2.42 degree. So omega s will come around 87.8 degree. Okay, so omega s will be around 87.8 degree. So this is the omega s. Now the sunrise hour angle, will be minus 87.8 degree, and sunset hour angle will be plus 87.8 degree. This is for the surface. This is for the horizontal surface, not the tilted surface. Okay, right now we have calculated the sunrise sunset hour angle for the horizontal surface. Okay, so we need to calculate the time of sunrise and sunset. Okay, so in order to calculate time of sunrise and sunset, first we need to divide this omega s by 15. So 87.8 by 15, it comes around 87.8 divided by 15 is around 5.853 hour. If we consider it in hour and minutes, so 0.8533 into 60, so it is 5 hour and 51 minute. Okay, 5 hour and 51 minute is the time. Now we can calculate the time of sunrise and time of sunset. So consider noon 00. Okay, so the time of sunrise will be before this consider it as 12. Okay, 12 or noon. Now the sunrise will be behind this. Okay, so it is 12 minus 5 minus 51, so it is around 6:09 a.m. Okay, it is, so this is the sunrise time, and the sunset time is simply 12 plus this 5 or 51 minutes, means 5:51, sorry, not am, pm. This is the sunset time, and this one is the sunrise time. Okay, so this way we can calculate sunrise and sunset time. What else we need to calculate? The solar altitude, zenith, and solar azimuth angle. So for solar altitude, let's use some other names here. So solar altitude, the formula I have written here. So yeah, sine alpha is your altitude angle. So sine alpha is sine delta sine L plus cos delta cos L cos omega. So if you put all the values, we already have delta L and omega, you will get sine alpha is around 0.337, so alpha will be 19.7 degree. Okay, so for the zenith angle, so as we already know, theta z plus alpha is 90 degree. That means the zenith angle and the altitude angle both are complementary to each other. That means their sum will be equal to 90 degree. So we can calculate theta z as 90 minus alpha, which is around 70.3 degree. So we have calculated altitude angle alpha as well as theta z. Okay, that means zenith angle. Now the next in the line is the solar azimuth angle. Okay, so solar azimuth angle gamma s is, so it is formula is sine of omega, means so we consider sign convention both omega and gamma as same. However, there is the difference between the gamma s and omega because they are calculated with respect to different point. Okay, but we consider the same sign convention, or we follow the gamma s, not again gamma s, it is az. Okay, solar azimuthal angle. So we follow the same sign convention as omega for az, that is solar azimuth angle. So sine omega is sine of omega into cos inverse cos theta z sine L minus sine delta divided by sine theta z and cos L. Okay, so if you calculate all the values, it turns out, just a moment, I can calculate it. So cos theta z, and theta z is 70.3 into sine L. L we have here 43 degree, so L is 43 minus sine delta, and delta is, we have calculated, minus 2.42, so it's minus 2.42 divided by sine theta z, that means sine 70.3 into cos latitude cos 43, and if we calculate this, it turns out around 66.8. Okay, so 66.8 degree is our solar azimuth angle. Now we need to, so all these angles are for the horizontal surface. Okay, and now we need to calculate it for this sloped surface. Okay, that means now I have a surface here whose tilt angle is 60 degree, and I need to calculate the sunrise time and sunset time for or with respect to this collector. Okay, so need to calculate at which sunrise and sunset occur on the tilted surface. Okay, so in the lecture this formula was given to calculate the to calculate the hour angle for a tilted surface. Okay, what was the formula? Cos omega s dash. So for the tilted surface, for all calculation for zenith angle, solar altitude angle, or for the surface azimuthal angle, we simply need to replace L, that means latitude, with L minus beta. Okay, because in the lecture it was shown that, for example, I have surface here, okay, which is making with the horizontal surface angle beta, and the latitude is L. If we move to somewhere here, if we move to this place, okay, we can find a location, okay, where this all the properties of this surface will be same here by considering a latitude as L minus beta. Okay, so whether we consider it as a latitude L and tilted angle beta, or consider it as a latitude of L minus beta, if we do the calculation, both the things will give the same value. Okay, so for the tilted angle, L is replaced by L minus beta. So the formula was mentioned in the lecture, that cos omega s dash is so earlier we have calculated for the normal like for horizontal surface, and this was the formula, minus tan L tan delta. So for this case, cos inverse minus tan L minus beta and tan delta. So if we calculate this, the answer is around so omega s is 9.73 degree, which is greater than 90, and we have seen that the omega s is from minus 90 to plus 90, it cannot be greater than 90, but here we are getting 90.73. so should we consider it as a 90 or what? See, the thing is, this formula is only valid when the surface azimuth angle is 0. Okay, so this formula is only valid when surface azimuth angle is 0. That means it is towards the south, and here we don't have surface azimuth angle 0. Okay, so surface azimuth angle is given as 25 degree. Thus we cannot use this formula. So what should we do? Now we need to calculate the sunrise and sunset on this tilted plane. So we have already seen that for sunrise and sunset, the zenith angle or the incident angle of the sun rays is 0. So that means theta I equals to, sorry, not 0, 90 degree. Okay, because it makes incident angle with the vertical 90 degree when sun is at horizon during sunrise or during sunset. Okay, so it makes 90 degree. So when sun is here, this is east and this is west. So sorry, we consider this as east west. So when sun is here, this is the sun is at horizon, so this angle will be 90 degree during sunrise, and similarly here during sunset again it is 90 degree. So for sunrise and sunset, theta equals 90 degree. So here we want to calculate the sunrise time and sunset time for this tilted angle. Okay, so that means the incident ray, okay, coming to this surface is making the angle with the normal to this surface 90 degree. Okay, so that means this theta tilt. So when this theta t equals 90 degree, that means that is the time when the sunrise or sunset is occurring for this tilted plane. So we can use the formula of cos theta t to calculate the hour angle when theta t equals to 90 degree. Okay, so we can, so I don't need to write the formula again. Okay, so cos theta t equals to, I have a very long expression, I am not writing it again. So theta t is what, 90 degree, so this will be 0. So I am writing the final expression, which is around 0.008499 plus 0.9077 cos omega plus 0.3657 sin omega. Okay, so simplify it, it is 0.3657 sin omega plus 0.9077 cos omega and equals to minus 0.008499 divided by 0.3657, it will be sin omega plus 0.9077 divided by 0.3657. I am dividing the coefficient of sin omega with the others, so it is 2.482 cos omega and here 0.008499 divided by 0.3657, so it is minus 0.0232. Now we also know that sin square omega plus cos square omega equals to 1. So I can write sin omega as root 1 minus cos square omega. So write it as root of 1 minus cos square omega and take all these to other side, minus 0.0232 minus 2.482 cos omega, square both the sides, will give. So I think I don't need to solve all the things. So if you solve, okay, so it is 0.0232 plus 2.482 cos omega. Okay, if you solve this equation, I'm writing the final expression because it will take a lot of time to solve this equation. You can solve it, it will be a good practice for you. So if we write the final answer, okay, so there, since it is a quadratic equation, there will be two value for the omega. Okay, so here omega is, the final answer for the omega is minus 68.6 degree and 112.4 degrees. Okay, so now this is minus 68.6 minus, that means this is the sunrise hour angle. So we can consider sunrise hour angle is omega s is minus 68.6. Since we have already written sunrise, don't need to use the minus sign. So it is 68.6 degree, and now we can calculate the total time with respect to solar noon for the sunrise time. So again divided by 15, so the answer is 68.6 divided by 15, around 4.57 hour, 4.5733 hour. if we convert it into minutes also, then it is uh, it is 30, sorry, so it is around 4 hour and 34 minute. Okay, 4 hour and 34 minute. So this is the sunrise time. So if we calculate it with respect to 12 noon, it is 12 minus 434, so it turns out sorry, 60 minus 34, 26, so it turns out around 7:26 am. Okay, so this is the sunrise time for the uh, tilted surface. That means at this time sun rays will make a 90-degree angle with the normal of the surface. And what is the sunrise time for the horizontal surface, that means the flat surface earth? It is 6:09 am. Okay, so you can say there is a lot of difference between the sunrise time of the plane surface, horizontal plane, and the sunrise time of the tilted surface. So if and here the tilted angle is 60 degree. Okay, so that is why there is a we need to define the or find out the exact tilted angle on which we will get the maximum solar radiation throughout the day. Okay, so yeah, this is the sunrise time for the tilted surface. And now we'll calculate the sunset time. So sunset, first sunset hour angle. Okay, so we have calculated, so we got two values of omega. One is minus 68.6 and there is 112.4 degree. Okay, now we can't consider this 112.4 degree since it is greater than 90 degree. Okay, so that means, so if we consider this sunset hour, that means this sunset is already happened for the tilt surface. Okay, that means the sunset hour angle is same as the sunset hour angle of the earth, and in this case it is 87.8 degree. Okay, so sunset hour angle is 87.8 degree for tilted surface. So that means sunrise time is different for horizontal plane and tilted surface, but it is same for both the tilted surface as well as the horizontal surface. However, we will see that when we calculate the solar radiation hitting to the surface, so after a certain angle, means after a certain position of sun in the sky, when the tilt angle is very high or very low, we will get a very less amount of solar radiation. We will see how this the solar radiation coming to the surface varies with the tilt angle, and of course with respect to the position of the sun. So when it is at the top of here, we will get maximum solar radiation. At sunrise and sunset, we will get minimal solar radiation, but it also depends on the tilted surface. Okay, the tilt angle of the surface. So yeah, that's it from my side for today. If you have any question, please ask. So so for this we have seen that we have covered almost all the important angles needed to calculate the amount of solar radiation coming on the surface, or to calculate the direction of incident solar radiation on the horizontal surface as well as on the tilted surface. Okay, all these things has been done to calculate the incident angle of the solar radiation on horizontal as well as on the tilted surface. And for that we need to know the declination angle, surface azimuthal angle, solar azimuthal angle, the hour angle. Okay, uh, and now here we have also seen that this latitude declination angle omega calculated or measured with respect to the center of the earth, that is why these are called the central angle, whereas this theta z, that is zenith angle, uh, and this surface azimuth angle, solar azimuth angle, these are calculated at the surface level. Okay, that is why it is called the surface azimuth angle. And then we consider the sign convention, hour angle, negative in the morning, positive in the afternoon, and solar azimuth angle is positive in the west and negative in the east. And also with respect to time, it follows the time convention of hour angle omega. Then we did the first question, calculate the angle of incidence of beam radiation for a tilted surface in Mumbai. So we have first, it is the simple formula based question. We calculate all the input required for the calculation of incident angle. Then we use this formula to calculate the incident angle on the tilted surface. Now for this second question, this requires more time, and there were lot of things to calculate, like time of sunrise, sunset, solar altitude, zenith angle, solar azimuth angle. So we have not only on the horizontal surface but also on the tilted surface. So for the horizontal surface we use simple formulas to calculate it, but for the tilted surface this formula means simply replacing L by L minus beta won't work, because this formula is only valid when the surface azimuth angle is 0 degree. That means your surface is towards the south. Okay, and since here the surface azimuth angle is not 0, it is around 25 degree, we can't use this formula. So what we did, we calculated the we put theta t equals 90 degree for the sunrise or sunset at the surface. Okay, that means, so we use the formula of calculating incidence angle on this tilted surface. Okay, and we put theta t equals to 90 degree, that means cos theta t 0, and there we calculated 2 omega. Since the final expression is a quadratic expression, so we will get 2 omega. One is minus 68.6, other is 112.4. This is greater than 90 degree. We neglected this. We use this formula to get the sunrise time, that is 7:26 am. So that means the sunrise time for the tilted surface is greater than compared to sunrise time of the horizontal surface. Okay, and we also see that we saw that sunset hour angle is same for both the tilted surface as well as the horizontal surface. So yeah, the remaining session, that is session on the shading and also some sign convention thing, will be taken by Pawan in tomorrow's online session. So if you have any question, please ask, or I'll stop the recording and also stop the meeting. Okay, so no question, I guess. So thank you everyone. I am stopping the recording.